Good morning, class. We are looking at practice test number 4, module 4, chapter 8. Application of trigonometry, polar coordinates and vectors. Here's the second part, polar coordinates and vectors. So to refresh your memory, we want to plot the points in polar coordinates, reminding you that a pair having coordinates x, comma, y in a rectangular coordinate system, also known as a Cartesian coordinate system, has a polar coordinate of r, comma, theta. Here's the origin or the pole. Here's the positive side of the x-axis or the polar axis. So what we do, we start with the angle theta. 0 is the angle, so it's along the positive side of the x-axis. When it's positive, you take mark 2 on the right side. When it's negative, 2 on the left side. So 2 on the left side because it's negative. For this one, pi over 2 in essence is like the y-axis for the rectangular coordinate system. So you start with that, and how many? Just one tick mark. That going up 1 would be 1 comma pi over 2. So we want to find other polar coordinates for part B, which is 1 comma pi over 2. So I want to remind you that x and y is unique, but r and theta, that's not the case, because you can add 2k pi. K is an integer, okay? Or if you want to negate the r, then you add odd multiples of pi. Pi plus 2k pi means odd multiples of pi. In this case, r is positive. So we're going to go with 1, and we want theta between 0 and negative 2 pi. All you have to do, subtract 2 pi. Remember, 2k pi, even multiples. So if you subtract 2 pi, you get negative 3 pi over 2. In this case, you want to negate the r. So 1 changes to negative 1. In order for this to happen, remember, you go back to this one. You have to add odd multiples of pi. So all you have to do, add pi, because you want it to be between 0 and 2 pi. So add pi, and that gives you negative 1 with 3 pi over 2. We want r to be positive, so we keep the 1. And between 2 pi and 4 pi, just add 2 pi to pi over 2. And that gives you 5 pi over 2, which is between 2 pi and 4 pi. So very straightforward, everybody. Again, just reminding you of that. So plot the points, find the coordinates, and the given question is 6 comma 150 degrees. So you make 150 degrees angle, and then you count how many? 6 tick marks. 1, 2, 3, 4, 5, 6. It may not be to scale, but we are having a polar grids. Those are circles, if you will, with various radii. Reminding you that if we want to go from polar to rectangular, x equals r cosine theta, y is r sine theta. So x equals r cosine theta, 6 times cosine of pi over 5 pi over 6, or 150 degrees. Again, 150 or 5 pi over 6. On purpose, I wrote it as 5 pi over 6, although you get 150. Just to remind you, they are the same. Now, the 150 degrees or 5 pi over 6, the reference arc is 30 degrees or pi over 6. So cosine is the same as cosine of pi over 6, which is square root of 3 over 2. However, this is in the third quadrant, makes it negative. So 6 and 2 cancel each other. You get a 3 at top. So negative 3 square root of 3 is the final answer. Y equals r sine theta, and the same thing, the reference angle is pi over 6 or 30 degrees, which has a sine equal to 1/2 in the second quadrant. Sine is positive, so positive 1/2. Their product makes it positive 3. Therefore, this pair with polar coordinates can be written as negative 3 square root of 3 comma 3 in rectangular coordinate system. Finding the polar coordinates, we locate that by going 2 to the right, 2 down. That is the location. It's in the fourth quadrant. Then reminding everybody that x squared plus y squared equals r squared, tan theta is y over x, and you have to figure out the quadrant accordingly. So x squared plus y squared equals r squared. Let's put that into that formula, which gives us 8, and therefore r is square root of 8 or 2 square root of 2. The 4 comes out 2 square root of 2. Tan theta is y over x or negative 2 over 2, which makes it negative 1. And you should know theta is negative pi over 4. Or if you want to go with the positive, is 7 pi over 4. So we write it as follows. R is 2 square root of 2. Theta is minus pi over 4. 2 minus 2 in rectangular coordinate system corresponds to 2 square root of 2, comma negative pi over 4 in a polar form. If you want this to be positive, add a 2 pi and it becomes 7 pi over 4. So either negative pi over 4 or positive 7 pi over 4 means the same thing. Transform the polar equation R cosine theta equals negative 2 to an equation in rectangular coordinate and graph. First and foremost, we write R cosine theta is negative 2 on the one hand. On the other hand, we know X is R cosine theta. That means X must be negative 2, which is a vertical line. Vertical line. How about transforming the polar equation R equals 2 cosine theta to an equation in rectangular coordinate and graph it? First, let's remind everybody X is R cosine theta, R squared is X squared plus Y squared, and what is given, R equals 2 cosine theta. So those are some piece of information. So the technique is to multiply both sides by R. When we do that, this becomes R squared, this becomes 2R cosine theta, and R squared, which is X squared plus Y squared, equals 2X. So R squared equals 2X, that means this. And we're going to bring everything to the same side and put the X squared and 2X next to each other. So X squared minus 2X. So we have this, and as you know, this is B. So you want to complete this square, so you divide that by 2. And now you square it, therefore we need a 1. So after we find that, You have to square it. So this is x minus 1 quantity squared. This is y squared equals 1. So we are looking at a circle centered at 1, 0 with the radius 1. Reminding you of the following: x minus h quantity squared plus y minus k quantity squared equals r squared. So it is, the center is located at 1, 0, and then the radius is 1, so it looks like that. Transform the polar equation or cosecant theta equals 8 to an equation in rectangular coordinate and graph. Well, we know cosecant is 1 over sine. So we are going to write r over sine theta equals 8. Cross product gives us r equals 8 sine theta. We use the same technique as the previous one. We multiply both sides by r. That gives us r squared equals 8r sine theta. We also know that x squared plus y squared equals r squared, and y equals r sine theta. Therefore, this is the same as x squared plus y squared equals 8y. Moving the 8y to the left and doing the same thing, completing the square, everybody. This is b. You divide b by 2, you get minus 4. You square it, you get positive 16. So complete the square. We add the 16 to both sides, and we end up with the following, which means it's a circle which has a center at 0, positive 4, with the radius square root of 16 or 4. So 0, 4 is the center, and then a circle with the radius 4. In short, we notice this type of equation, r equals a number times sine or cosine, will end up being a circle. We want to identify these two. Those are also common. R equals 4. The easiest one would be to square it. Gives you r squared equals 4 squared or 16. So square both sides. And that means when r equals 4, x squared plus y squared equals 16, because r squared is x squared plus y squared equals 16. So it is a circle which is centered at the origin or the pole with a radius of 4. So r equals 4. Now, the advantage of the polar equation that it's easier when you compare these two to represent it. Theta equals 3 pi over 4. Let's take a tangent of both sides. So that's the circle. That's the circle. Centered at the pole or the origin. 1, 2, 3, 4. This one, Let's take a tangent of both sides. 3 pi over 4. Remember, it's the same as pi over 4. You look at the quadrant, the tangent is negative in this. This is the second quadrant. So tangent of pi over 4 is positive 1. 3 pi over 4 puts us in the second quadrant, and it makes it negative 1. Therefore, if you look at this one and you do the cross product, y equals minus x. Y equals minus x. So when theta is 3 pi over 4, we have a line that goes through the origin. Because it's y equals minus x, it goes this way, okay? So some line, so this represents some line through the origin. More specifically, y equals minus x, which goes this way. Let's look at these two equations. We want to identify the graph of the equation and convert to a rectangular equation. So identify, graph the equation, and convert. All of the above. So number one, r sine theta equals minus 3 reminds us as one of this, which is y equals r sine theta. And when you compare and contrast, the r sine theta can be replaced with y. So y equals negative 3, which you know it to be a horizontal line, okay? Because it's negative 3, 1, 2, 3, below the x-axis, the polar axis, if you will. It's a horizontal line. Our cosine theta equals 4. You know, our cosine theta is x, and therefore x equals 4. And x equals 4 is a vertical line because it's 4, 1, 2, 3, 4. It's a vertical line. So here's the theorem. Quickly, we're going to cover it. When r is a number, we have a circle centered at the pole or the origin with the radius a. If theta equals some number, theta equals alpha, we have y equals tan of alpha times x, which is a line through the origin or the pole. If we have r sine theta equals a constant, that ends up being a horizontal line. If r cosine theta is a, that ends up being a vertical line. So in this case, y equals a, in this case, x equals a. If we have r equals 2a cosine theta or minus 2a cosine theta or 2a sine theta or minus 2a sine theta, all of them represent a circle with the radius a. We are assuming a is positive. In this case, in the case of a cosine, the center is along the x-axis, a comma 0 minus a 0. In the case of a sine, along the y-axis, 0 a or 0 minus. That's a general idea. Symmetry in polar coordinates. We remember the odd and even symmetry in algebra. So, a rectangular coordinate system. Symmetry with respect to WRT, the polar axis, the x-axis. If in polar equation r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation, the graph is symmetric with respect to the polar axis, respect to this axis. So theta can be changed to negative theta. Symmetric with respect to the line theta equals pi over 2. Theta equals pi over 2 is the y-axis, remember that. If in the polar equation r comma theta can be replaced by r comma pi minus theta, The graph is symmetric with respect to the line theta equals pi over 2, the y-axis. So this is r comma theta, this is r comma pi minus theta, because this is the same as theta, right? Symmetric with respect to the pole or the origin. If in the polar equation r comma theta can be replaced by minus r comma theta or r comma theta plus pi, the graph is symmetric with respect to the pole, looking like that. So r comma theta, this one is minus r comma theta. That makes it symmetric with respect to the origin or the pole. We want to graph r equals 1 minus cosine theta, and there are different ways to approach them. You can basically plug in and do the math, but a couple of things I want to explain. A cardioid is in the form of r equals a times 1 plus minus cosine theta or 1 plus minus sine theta. That's the shape. Almost looks like a heart. A is positive and it passes through the pole. So that to give you an idea. Now, to graph this, the best way is to pick up pairs. That's all you have to do. And I like to go with the easy pairs, okay? So if we pick those values, whether 1 minus cosine theta, okay? So 0, if you plug in here, gives you 1, 1 minus 1 is 0. So 0 gives you 0. Pi over 6. 1 minus cosine of pi over 6, 1 minus square root of 3 over 2. Pi over 4, 1 minus cosine of pi over 4, square root of 2 over 2. Pi over 3, 1 minus cosine of pi over 3, which is 1/2, 1 minus 1/2 is 1/2. Pi over 2, this is 0, makes it 1. 2 pi over 3 is the same as pi over 3, but it makes it negative, because in the second quadrant, cosine is negative. So minus negative 1/2 makes it positive 1/2. So 1 and positive 1/2 is 3/2. If you plug in pi, you get negative 1. Minus negative 1 gives you plus 1, so it gives you 2. So I'm assuming everybody can easily plug in. So let's write the pairs. Zero, 0. You start with theta, remember that. Pi over 6, so pi over 6. Okay, so pi over 6. And 1 minus square root of 3 over 2. You have to sort of go with the decimal representation to have an idea, okay? So what I want to do, actually, I want to go with the easy ones, this one, 1/2 pi over 3. So I'm assuming this is 1/2, this is 1, this is 3/2, and this is 2, roughly. 1 and pi over 2. Pi over 2 is up here, right? Because it's pi if it were negative 1 down there. So 1 along this. Okay. Remember, this is half, this is 1. Two pi. So remember, this is pi. So this is 0. This side is pi. So we want 2, 1/2, 1, 3/2, 2. Okay, this one. This is like 3/2, 3/2 pi over 2. So if I put them all together, see, I go like that. And it looks like this. Needless to say, this is much more precise. We can discuss the symmetry as follows. If we replace the theta with negative theta,
Sorry,
1 minus cosine of minus theta. Cosine of minus theta is the same as cosine of theta, and nothing changes. When r comma theta can be replaced by r comma minus theta, we have symmetry with respect to the polar axis, with respect to the x-axis. So this one, the same thing at the bottom, the same thing, right? By symmetry. R comma theta can be replaced by r minus theta. So we can also continue by evaluating the easy ones such as 4 pi over 3, 3 pi over 2, 5 pi over 3, and 2 pi. Just as an example, for 4 pi over 3, remember the reference arc is pi over 3. So it's the same as pi over 3. Cosine of pi over 3 is 1/2. However, this is in the third quadrant, which makes it negative. So 1 minus negative 1/2 makes it positive 3/2. 3 pi over 2 makes it 0, so it's 1. 5 pi over 3 is the same as pi over 3. So it's 1/2. 5 pi over 3 is in the fourth quadrant. In the fourth quadrant, cosine is positive. 1 minus 1/2 makes it 1/2. And 2 pi gives you 1. 1 minus 1 is 0. So you can use those if you want. And graph the rest of it. So you can use the concept of symmetry, or you can use more pairs. Both ways will do the same job. Again, a quick recap. Just use easy angles. Figure out the angle, figure out the R, plot, and you're done. Every possible point from 0 to 2 pi. That's one way to do it. I did it from 0 to pi. Then I showed the symmetry, and I said you can just use the concept of a symmetry, or you use more points. That's all you have to do. Carefully draw it, and it works. All right, plot the complex number 1 plus I in the complex plane and write it in polar form. Write theta in degrees. Let's remind everybody of a couple of things. Z equals x plus yi, r cis theta, which means r cosine theta plus r I sine theta. That's the concept. R squared is x squared plus y squared. The modulus of z, or the magnitude of r, is square root of x squared plus y squared. Tan theta is y over x. As always, you figure out the quadrant. These are the information we have, where z is a complex number, and remember, I by definition is square root of -1. So with that being the case, to give you an idea, this is x plus iy, and this is the conjugate, complex conjugate. This is the distance r, this is the angle theta, okay? And so this is y, this is negative y, this is the x-axis is the real axis, the y-axis is the imaginary axis, all right? So plot the complex number. So the way it works, along the x-axis, along the real, we are going to go 1, 1 to the right, and I. The coefficient of I, a positive 1, you go up, positive 1, negative 1, you go down, positive 5, you go up, positive 5, negative 5, you go down, okay, 5 units. In this case, 1 and 1 in essence. So 1 to the right, 1 up, okay? So let me just actually write this number in it. So this means 1 plus 1i, okay? I want to make sure that we understand. And so r is square root of x squared plus y squared. So we're going to add 1 squared and 1 squared. That gives us 2, and r becomes square root of 2. So that's the graph, that's the r. We want to find tangent theta, which is y over x. 1 over 1 is 1, and it's in the first quadrant. Theta becomes pi over 4 or 45 degrees. Divided in degrees. So we write z, which is 1 plus I equals r cis theta. This r cis theta is the shorthand notation. So r is square root of 2 and theta is 45 degrees. Polar form. Complex number, polar form. Right, the complex number 4 times cosine of 7 pi over 4 plus I sine of 7 pi over 4 in rectangular form, and plot the complex number. And again, I'm reminding you of the formulas. So 7 pi over 4, remember the reference arc is pi over 4. Cosine and sine of pi over 4, both of them are square root of 2 over 2. 7 pi over 4 puts us in the fourth quadrant, so cosine is positive. However, sine is negative, so because of the quadrant. Now 4 cancels out the 2, both of them go away, so this is 2 square root of 2 minus 2 square root of 2i. 7 pi over 4 or minus pi over 4. So somewhere here. And how many tick marks? 4, if you will. That's the concept. So along this line, 4 tick marks, or along this one, 2 square root of 2, down 2 square root of 2. Either way is fine. That's the point we are interested in finding. Find z times w and z over w and leave the answer in polar form. Z is given as 2 times cosine of pi over 8 plus I sine pi over 8, and w is given as 2 cosine of pi over 10 plus I sine of pi over 10. Reminding you of the following. Here's z and the information about the z. Here's their product. Z1, Z2 is R1, R2, cis theta 1 plus theta 2, which means if you want to multiply two complex numbers in polar form, multiply their modulus, their magnitudes, and then cis add up their arguments. If you're dividing, divide their modulus, divide their magnitude, and cis theta 1 minus theta 2. Okay, the difference of their arguments. Therefore, I want z times w. I want this times this. And I'm going to stick with this formula, which means I'm going to say 2 times 2, 2 times 2, cis theta 1 plus theta 2, pi over 8 plus pi over 10. Now, this is a shorthand notation. When we say cis theta, it means cosine of cis theta 1 plus theta 2, cosine of theta 1 plus theta 2, plus I sine of theta 1 plus theta 2. That's the shorthand notation. Of course, 2 times 2 is 4. Now let's add pi over 8 and pi over 10. Their common denominator is 40. So 40 divided by 8 is 5 pi. 40 divided by 10 is 4 pi, so we get 9 pi over 40. So 4 cis 9 pi over 40. And we're going to leave it in polar form. Let's do the division. The division says R1 over R2. So this is the first one, okay? Z is the first one. 2 divided by 2. And then first, let's just plug in this divided by that. And then now 2 cancels out the 2. And this becomes basically cis pi over 8 minus pi over 10. Pi over 8 minus pi over 10. If you recall, we decided 40 is the common denominator. So the first one gives us 5 pi, the second one 4 pi. So the answer is pi over 40. So cis pi over 40 or cosine of pi over 40 plus I sine of pi over 40. We want to raise this to the power of 6. So reminding everyone about what's called De Moivre's theorem. If you have a z as RC theta and you want to raise it to the power of n, raise the modulus or magnitude to the power of n, and then multiply the argument theta by n. So we want z to the power of 6. That means we're going to raise this one to the power of 6. And then we're going to multiply this one by 6 according to this. De Moivre's theorem makes it very easy. I hope you realize square root of 3 to the power of 6 means 3 cubed. Now this one, 6 goes away, 18 becomes 3. Now 3 cubed, everybody knows it's 27. You can leave it like that. 27 cosine of 5 pi over 3 plus I sine of 5 pi over 3. Now, you could also write as pi over 3. If you change this to pi over 3, that works out for cosine. But for the sine, you have to go with the negative because sine of 5 pi over 3 is negative sine of pi over 3. Again, if you just want to go with the first quadrant, you don't have to. This is fine. This is fine. And now we want to write it in standard form of a plus bi. So cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. So basically 27 halves minus 27 square root of 3 halves I. Sometimes they put the I in between. It's important to know I is part of the numerator and it's not under the radical. Okay. So the notation they use various notations depending on the text. We want 1 plus I, z given as 1 plus I to the power of 10. So z to the power of 10, and we are going to use De Moivre's theorem. And we have to first put this in polar format. We had done that. If you go back to question number 9, we did this. So I'm not going to go over that again, but we have the detailed solution there. So therefore, if you want z to the power of 10, basically raise this one to the power of 10. and then multiply this one and this one by 10. So this one to the power of 10, and multiply the argument 45 degrees by 10. So the modulus or magnitude raised to the power of 10. Square root of 2 to the power of 10, that means 2 to the power of 5. 10 times 45 is 450 degrees. Now 2 to the power of 5, everybody knows, is 32. 450, let's subtract 360. It's the same thing. Let's go with a complete, just the first revolution. So it becomes 90 degrees, right? Cosine of 90 is 0. Sine of 90 is 1. So 32i. In general, when you have the format 1 plus I or A plus BI or X plus YI, where A and B and X and Y, the real and the imaginary values are the same. See, the coefficient of these two, the coefficient of I is the same as this one. It ends up with some number times I in general. That when you raise it to the power of even, then you raise it to the power of even. Let's look at the next example. Z is given as 8. We want to find all complex cube roots. These are the stuff we have seen. Let's discuss the cube roots in the case of a polar format. If W is R, cis theta sub 0, where n is larger than or equal to 2, there are n distinct complex nth roots of W. So Z sub k is the nth root of R, cis theta 0 over n plus 2k power n. And of course, if it's degrees theta 0 over n, this one we put 360k. Please understand these two are the same. And you choose k to be 0, 1, 2, all the way to n minus 1. When you have a real number, notice the imaginary part, see a plus bi. When b is 0, you have a real part, you have a real number only. And so we can replace that any number with really cis 0. So So z equals 8, we have a and b is 0, and so the angle that it makes with the polar axis is 0. That's why r cis theta, the value of theta is 0 degrees. So we can write it as 8 cosine of 0 plus I sine of 0. If you plug in, you see that it ends up being what you have. This is 1, this is 0, or you can with the shorthand notation write down 8 cis 0, or simply 0 degrees. All right, so according to this formula, since we want the cube root, n is 3, so we want the third root of r is 8, everybody. Theta sub 0 happened to be 0, and n is 3. So cube roots, this means n is 3, okay? And this is your r. And so this is 0, basically has no bearing. This is 2. So you end up with 2 cis 2k power 3. And we are going to go all the way to n minus 1, meaning 0, 1, 2. N minus 1. N is 3. N minus 1. So you plug in 0, you evaluated 1, evaluated, so on and so forth. So if I plug in 0, 0, 2 pi over 3 if I plug in 1, and 4 pi over 3 if I plug in 2. Now 0 gives me 2. 2 cosine of 0 plus I sine of 0, as you know. This is 0, this is 1, so it's 2. And of course, as a real number, z equals 8, you know the cube root is 2. Now, for the second part, z sub 1, now cosine of 2 pi over 3 or sine of 2 pi over 3, the reference arc is pi over 3. And cosine of pi over 3 is 1/2. But 2 pi over 3 puts it in the second quadrant and it makes it negative. However, sine is positive in the second quadrant. So 2 times negative 1/2 makes it negative 1. And 2 times square root of 3 over 2 makes it square root of 3. So it's negative 1 plus I square root of 3. What about the last one? Z sub 2, 2 is 4 pi over 3. Again, the reference arc is pi over 3. In the third quadrant, cosine is negative, so it becomes the same thing, negative 1/2 here. But what about sine? Sine is also negative. In the third quadrant, both of them are negative. So square root of 3/2 will change to negative square root of 3/2. So let me write that. So this one, negative 1/2, negative square root of 3/2. So this gives us negative 1. This gives us minus I square root of 3. Okay. So the point being, z equals 8. If you want to take a cube root, in essence, it corresponds to the following equation in algebra. Find the x values, and x must have, is of degree to degree, must have 3 complex solutions. They're all, remember, even 2 is considered complex if the imaginary part is 0. And that's how you solve. All right, let's switch gears. Vector V has initial point P and terminal point Q. Write V in the form of AI plus BJ, its components, if you will. Find its position vector, also find its magnitude. And P 3, 2, Q 5, 6. This is the initial point, and this is the terminal point. So let's remind everybody of a couple of things that we discussed regarding vectors. So if you look at this vector with the initial point x sub 1, y sub 1, and terminal point of x sub 2, y sub 2, this distance is x sub 2 minus x sub 1, this distance is y sub 2 minus y sub 1, and if we start from the origin, it becomes the position vector. So let's look at these definitions, reminding everybody if a v vector with components a, b is an algebraic vector whose initial point is at the origin, then v is called a position vector. Algebraic vectors, v is ai plus bj, or just in this format, a comma b. A and b are called components of the vector v. A vector with initial and terminal points p and q is equal to the position vector V or PQ vector, x sub 2 minus x sub 1 comma y sub 2 minus y sub 1. So with that being the case, let's use it here. X sub 2 minus x sub 1, 5 minus 3. Y sub 2 minus y sub 1, 6 minus 2. And that gives us 2, that gives us 4. So those are the components. And we can write the vector as coordinates 5 minus 3i plus 6 minus 2j, or simply use those that you found, 2i plus 4j. These two mean absolutely the same thing. We want to find the magnitude. Well, reminding everybody about the magnitude. The magnitude is square root of a squared plus b squared. It's non-negative. If it's 0, the vector must be 0. Two opposite vectors have the same magnitude. If you multiply it by a number, this is scalar a, you can take it out and put in an absolute value. So using this formula, we have 2 squared plus 4 squared, which is 4 and 16, 20. And square root of 20 is 4 times 5, and 4 comes out as 2, 5 remains. This is the exact answer. So in short, initial point and terminal point, if we have both of them, we can come up with the components and the magnitude easily. Now, V is negative 2i plus 3j, and W is 5j minus 4j, and we want to find the magnitude of V plus W, and 2V minus 3W, and reminding everybody of what we just said here. And as far as the vector addition is concerned, the associative property and the commutative property, both properties work. U plus V plus W, the way it works, you start with one of them, and then the terminal point of V goes, the initial point of V goes to the terminal point of U, and then the initial point of W goes to the terminal point of V, and you connect them, and the resulting vector would be from the initial point of U to the terminal point of W, just to give you an idea. So this one, obviously, we use this formula, and V, so minus 2 quantity squared plus 3 squared. We are looking at the V vector, everybody. So that would be 4 plus 9. We want the sum of the two, just add up the components accordingly. Basically, negative 2i and 5i gives us 3i. Positive 3j, negative 4j gives us minus j. That's all we have to do. Two V minus 3W. So 2 times this vector minus 3 times this vector. Minus 4i plus 6j minus 15i plus 12j. Minus 19i plus 18j. Find the magnitude, direction, angle, and a unit vector in the same direction for the following. V equals 3i plus 3j. Well, we know the magnitude is square root of a squared plus b squared, which makes it 9, and 9 is 18, which is 3 square root of 2 because this is 9 times 2, and 9 comes out. So we got the magnitude. We want to go with the direction, angle. So let's remind everybody what we mean by that. A vector V is represented as the product of its magnitude and cosine alpha cis, if you will. Cosine alpha I plus sine alpha j. Direction angle alpha is between 0 and 360, and it's between the vector and the I component. In other words, the x-axis, the positive side of the x-axis. All right, so here's the V. We want to find the angle, so we go with the tangent, obviously, which is tan of alpha is b over a, b over a, b over a. This is ai plus bj. Let me just write that top of ai plus bj, and tan is b over a, b over a. Which is 1, and it makes it 45 degrees or power 4. Therefore, if we want to write it in this fashion, you just plug it. The magnitude, we have 3 square root of 2, and alpha, we have 45 degrees. So the I component and the J component, everybody. The I component would be 3 square root of 2 times cosine of 45i, and this is 3 square root of 2 times sine of 45 degrees j. Okay, which ends up being 3i plus 3j. But this is using with the direction angle. Unit vector, by definition, in the same direction, all you have to do, divide the vector by its modulus or magnitude. So divide this by its magnitude. That's all you have to do. That's a unit vector. So this is the unit vector along the x-axis, or the I vector, or the j vector, ai plus bj. So a times 1, 0, plus b times 0, 1. In any event, so divide by 3 square root of 2 and separate them accordingly, and simplify them. And I hope you see this actually goes away, becomes 1 over square root of 2. 1 over square root of 2 is the same as square root of 2 over 2. Okay, I write it here. 1 over square root of 2. If you multiply by square root of 2 over square root of 2, you get square root of 2 over 2. So that's a number we should be familiar with. It's really not a big deal. Write a vector v in the form of ai plus bj given its magnitude and the angle alpha. It makes with the positive x-axis. Also find the unit vector and check its magnitude to be 1. The magnitude is 14, and the angle it makes is 120 degrees, or alpha is 120 degrees. So we just use this formula. We replace this with 14 and the alpha with 120 degrees. Now, remember, with 120 degrees, the reference arc is 60 degrees. In the second quadrant, so cosine of 60 degrees is positive 1/2. In the second quadrant makes it negative 1/2. Sine is positive in the second quadrant, which is square root of 3 over 2. Again, reminding you of the reference arc. 14 divided by 2 makes it minus 7i, divided by 2 plus 7 square root of 3j, and To find the unit vector, all you have to do, divide this by the magnitude 14. So this becomes -1/2, and this becomes, so -1/2 I, this becomes square root of 3/2j. So we got this, we got the unit vector, and we want to check. To check, you square this number and this number to find the magnitude of this new vector must be 1. So when we square this, plus square this, this gives us 1/4. This gives us 3/4, which is 1, and square root of 1 is 1. So you can easily prove that, and that's really a good way to check. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of the plane to the nearest mile per hour and the true course of the plane to the nearest tenth of a degree. So this one is given as a north 55 degrees east. This is going 200 miles per hour. So what we have is this one is 35 degrees. Right? If this is 55 degrees, this one must be 90 minus that. So we have velocity relative to air given as 200 miles per hour, theta of alpha. This one is 90 minus 55, which is 35 degrees. Here's the way the wind blows, which means 35 miles per hour, and the angle that it makes, it's parallel to the x-axis. Because west to east, that means the angle must be 0. And if that is the case, this is the true course. If this angle, we call it theta, and this is the velocity with respect to the ground or the true course, then this angle must be found, and then we have the magnitude, that is the ground speed, and the true course would be going what? This way, right? North 90 minus theta. We call this theta, right? 90 minus theta east. Please understand, we are talking about this one, right? So we want to find the magnitude, and the angle theta is found. So this green one, 90 minus theta. All right, let's write VA and VW and add them up component-wise. So this is 200 cosine of 35 degrees I plus sine of 35 degrees J. Now this, you put it into a calculator, gives you the following. You have to use a calculator. For the wind, we don't need a calculator because cosine of 0 degrees is 1, sine is 0, so it's simply 35i. So we want to find the velocity relative to the ground. We have to add them up. So when we add them up, let me use a different. We add up their components. These two add up because they both have I and just 114.72j. So that would be the vector format. How do you find the magnitude when you have the components? Square root of a squared plus b squared. Square this number, add them up and take a square root. Putting it into a calculator results in 230 miles per hour. So we have this one. What about the true course? We want the tan of theta tan of theta is B over A, or alpha, B over A, this number over this number, 114.72 over 198.83. And using a calculator, theta is tan inverse of this number. So we have theta, 29.98 degrees. It says 10th of a degree, so it becomes 30 degrees, or 30.0. We want 90 minus that. That gives us 60 degrees. So 230 miles per hour north, 60 degrees east.